Take two. Sorry, Mr. O'Neill's class was a little loud. All right, so the diaphragm. Let's talk about the diaphragm. You can actually find your diaphragm. It's pretty much underneath your rib cage. So if you kind of like feel kind of like in there, it just feels like ribs. But what it is it's a division from your abdominal cavity, which you think abs, right? So think abs, your digestive tract is like your guts and whatnot in there. Your digestive tract is above it as well because, it needs to connect. But your thoracic cavity is what's above there, and that's going to have your lungs, your heart, and some other fun things in there as well. So the diaphragm divides these two. And so when your diaphragm is relaxed, it kind of looks kind of like this, where it's kind of like shaped up. And what happens is when you breathe in, it flattens out. And when it flattens out, that makes the space that your chest has larger. So by increasing the space in your chest, what you're doing is you're allowing air to be sucked into your body. So that's kind of how air moves into your body. It's just because you're increasing the space inside of your chest. Now, there's another thing that happens as well, which is your intercostal muscles of your rib cage, they actually flex also, they contract. And when they contract, they actually move out and up a little bit as well. So again, the space in there is getting bigger, which means the pressure goes down, so then you can get more volume in there. So you get the air to come in. So it's interesting that that's how you breathe. Okay, so the diaphragm does all of that. It helps ventilate your lungs, which is again causing air to enter and circulate freely in. So to get air into your lungs, you're going to use your diaphragm and those intercostal muscles of your rib cages. Okay, so in mammals, air is inhaled through the nostrils into the nasal cavity. Air is filtered by hair and mucus. So we don't really think about this much, but you have nose hairs in there, and what they're doing, and then you have like mucus as well up in there, and what it's all doing is as you breathe in, it's just grabbing dust particles, bacteria, yeast, all that stuff that's in the air. So it's grabbing all of that so that it can prevent it from going into your lungs. And viruses, it's grabbing viruses too. It's not perfect, as we know. That's why we're wearing masks, right? Because we can't grab, all of those. Some of them get into your lungs. And that's how you'd normally get sick too. If somebody coughs near you and you breathe in those particles, yes, your nose and whatnot will filter out some of it, but some of it might make it to your lungs and, you get infected from there. So that's one of the big things that the nasal cavity does. It also warms and humidifies whatever air goes in. So, it's real dry in the winter. So if you breathe through your nose, you breathe in, moistens that and humidifies that air, and then it goes to your lungs. Super important to have moist air in your lungs, because if you have dry air in your lungs, it's going to dry out your respiratory surface. So gas exchange is not going to be able to work as efficiently as possible. Because remember, one of the requirements for gas exchange is your respiratory surface has to be moist. So you need that humidified air. So that's why breathing through your mouth is not a great idea. And like running and stuff, you don't want to breathe in through your mouth, right? Isn't the whole thing like breathe in through your nose, out through your mouth? I don't know, I'm not a big runner, but I think I've heard that before in gym class, right? Something like, give me a couple nods. Does that sound good? Yeah, any cross-country runners we have in the chat? No? All right, no problem. I'll have to go find Smitty. He would know. All right, so it's better for you if you breathe through your nose for all these reasons we just talked about. All right, awesome. So you will need to know the path that air takes as it enters your nasal cavity and makes it to your lungs. We're going to go through, we're going to talk about this path, all right? So first up, it says, from the nasal cavity, air next passes to the pharynx, which is another name for your esophagus. And this is where both air and food, they travel through these. This is where you have, this is close to where you have that issue where if you drink water too fast, goes down the wrong tube and you feel like you're choking. Everybody's done that before, right? I do it like daily. I don't know what's wrong with me, but I just can't drink water for some reason. So yeah, that's because you're having some issues with some of this stuff, which we'll get into. Okay, so the esophagus, both air and food move through this. Then there's the larynx, and it goes past the vocal cords, which, used in speech and singing and all that. Some cool things about this system: when you swallow food, the larynx moves up and tips the epiglottis over the opening of the trachea, so food doesn't go down in there. So every time I'm choking on water, I'm like, epiglottis, you got me, because it all didn't work out perfectly, so that's tragedy. When you breathe out, air moves past your vocal cords, and by tensing muscles, you can make sounds. And we do this without even thinking about it, without even using Grammarly. Look at this. Today, not brought to you by Grammarly, all right? Maybe they'll sponsor this video, right? Maybe there's an ad right here for it. No? All right, anyway. So if you tightly stretched, it makes higher sounds, and loosely stretched, it makes lower sounds. And this is why your voice might be a certain kind of like pitch, or have a certain kind of characteristics to it, because it naturally will have like different characteristics from this, which is pretty interesting. So I threw it in there. All right. So into the trachea, which is the windpipe. So now we're into the windpipe. It's held open by cartilage rings, and you're like, I can't imagine all this stuff. Don't worry, I'm going to show you a photo in a second, or a picture. The trachea then forks into two bronchi, which is the plural for bronchus, and I always think brontosaurus, but that's way off, right? Bronchi is plural, bronchus is singular. The bronchi splits into smaller bronchioles, and finally, at the end of the bronchioles, there are the alveoli, which is where gas exchange takes place. And I know I skipped some stuff, so we'll go back in a second. But that's where gas exchange takes place. This is what our goal is for air, to get into that spot. Okay, so let's go back up to the bronchioles real quick. So you've heard of bronchitis, right? Bronch, it has that same kind of, part of the word. So when the bronchioles become inflamed and constricted, it makes breathing difficult. So bronchitis, you're having issues with your bronchioles. And if you have asthma, you've probably experienced this before as well, because you have issues with breathing, during an asthma attack. Similar kind of situation where, they're constricting when you want them to relax so you can get more air in and out. Okay, so let's jump to the alveoli, and I want to show you a picture of it so you can really imagine what it means by these grape-like clusters of air sacs where gas exchange occurs. Okay, so here's our runner, and so when she breathes in, air's going in through her nose, going to the sinuses, getting hydrated, filtered, right? All that kind of stuff's happening. And then we have it moving to her pharynx, esophagus, larynx, the trachea, all right? We have the right lung on the left side, right? We talked about the heart and how they're named on opposite sides because it's your perspective. When you're looking down, it's on the right side. Like this is my left heart or lung. This is my right. Now I can't think. This is my right lung. So it's opposite when you're looking at it from somebody else's perspective. So again, trachea, and then it breaks into the bronchi, but there's only one on this side, so that's why they wrote bronchus. Then the bronchioles are all these little extensions down here. And you can't see, but at the tip of those, you have the alveoli. So here we have air, and that's air from outside all the way into your lungs, on the inside of your lungs, all the way down to your alveoli. And again, it's in here. This is that air. It's on the inside. It goes up against the very thin epithelial cells, right? And then it allows gas exchange to take place. So we have gas exchange where oxygen is going out of the lungs into the blood, and carbon dioxide is coming into that airspace because there's a lot of carbon dioxide in the blood. So you have that diffusion taking place in there, all right? And you can see on the bottom, the diaphragm also has that kind of shape to it, and then as you're breathing in, it kind of flattens out more. And your heart's in there too. Okay, any questions with any of that? Any of the parts of the lungs or the whole system? Anything? All right. Okay, so let's talk about the alveoli, because that's where the magic's taking place. That's where the important part is. So the alveoli are well adapted for gas exchange with high surface areas for the capillaries. So you have millions of alveoli in your lungs. On their surface, they have thin epithelial cells where gas exchange takes place. Remember, they want to be really thin so that gas exchange can be as quick as possible. So you get all the oxygen into the blood as fast as possible, all the carbon dioxide out of the blood as fast as possible. Okay, so in the alveoli, O2 diffuses into the blood and CO2 diffuses out of the blood. And my question for you is, why? Why does O2 go into your blood? What makes diffusion work is a more broad question. Cue up the Jeopardy music, although I can't play it because then I'd have to pay some rights. All right, yes, to get to the rest of the body once it's in the blood, which is important. But my question is to you, physically, mechanically, why does the oxygen go into the blood? Why does it diffuse into the blood? Jewel?
There's less oxygen in the blood, so it wants to when there's less oxygen.
Good, good. There's less oxygen in the blood, like you just said. There's more oxygen in the lungs. So it's going to go down a concentration gradient, right? It's going to go from an area of high concentration to an area of low concentration. So it's going to go from the lungs into the blood. And CO2 is going to do the exact opposite thing. In the blood, we have a lot of CO2, and it's going to diffuse out into the lungs because in the lungs, there's less CO2. All right, so we have diffusion working both ways here, which is great. All right, so yeah, great job. Okay, so now we have kind of like this interesting thing where if you probably never thought about this, but if you breathe out all the way and all the air is out of your lungs, why don't they just stick together? Why don't they get sticky? Why do they open back up? A couple things. One, when you breathe out, you really don't get all the air out. There's always air that's in there. And if it doesn't move, or, if it doesn't leave your lungs, they actually call it dead air because it's just air that's just hanging out in your lungs, which sounds kind of like ominous. But it's not really a big deal because if you have dead air in there right now when you breathe out, the next time you breathe in, that air that was in there mixes with the new air, and then you might breathe it out the next time. But anyway, another reason that it doesn't stick together, your alveoli don't stick together, or it doesn't collapse, is because of these surfactants, all right? And surfactants are specialized secretions required to keep the walls of the small alveoli from sticking shut when you exhale. So they literally make it slippery, all right? Now, you may have heard of this word surfactant before, because it actually is used in chemistry, and even like on a basic level, it's used in soap. And that was a really bad joke, because I said even on a basic level, it's used in soap, and soap's basic. And I know. All right, I'll say it again next year after we do acids and bases, and maybe it'll be funnier. Yeah. Well, we'll see, Thanks, Carson. I appreciate the laughing. All right. So, surfactants, they make things slippery, right? So soap, slippery. All right, cool. So anyway, these are in there to keep your lungs from sticking together, right? Very important. Now, here's a sad fact about this. Babies that are born 6 weeks or more before their due date, they can struggle because they don't naturally have those surfactants ready to roll yet. So what doctors and scientists have figured out is how to make artificial ones that I'm assuming the babies then, they'll breathe in, and then it'll get into their lungs. So then they can actually breathe much easier once they have these artificial surfactants in their lungs. And then once they grow, a couple weeks later, they'll start making their own. So then they don't have to, they'll struggle less, which is great. Which is pretty cool. Okay. Now, let's start talking about how to destroy your lungs, all right? And this isn't like a how-to guide because you want to do this. This is more of like a how-to guide so that you don't do this, right? So first of all, exposure to pollutants can cause continual irritation and inflammation of the lungs. And some common lung pollutants include just general air pollution. So like if we lived in a city, that kind of stuff. There's tobacco smoke, there's vaping, marijuana smoke, any kinds of smoke. Like if we lived in California, we would need to be concerned with like wildfire smoke, all right? And you'd want to have like air filtration things in your house so that you don't breathe that stuff in. Because again, over time, it's going to damage your lungs. And there's this disease, this kind of classification of a disease called chronic obstructive pulmonary disease, which can cause some issues with you breathing. So it's a general kind of like term, and it's applied to people that have trouble breathing, and it's usually in people that had smoked earlier in life, but it can come from other things as well. And you usually have issues with breathing, so that's lung ventilation, all right, which means it's hard to breathe, and gas exchange. So this is when you can breathe, but you're not breathing efficiently, and like the oxygen's not getting into your blood as efficiently as it should. So if you have issues with these things, that's COPD, and it's a really terrible, terrible disease. You might need oxygen tanks, that kind of stuff. They're seeing that people that get COVID that have COPD, they don't do well. So that's why they're trying to vaccinate as many smokers as possible, because they, to save lives. That's that whole idea. With that. Okay, and then like I said before, so we have vaping as well. All right, so let's talk about vaping real quick. Macrophages are a type of immune cell, and they keep the surfactant healthy by finding and recycling damaged proteins, as well as killing inhaled viruses and bacteria. Big deal, right? If you breathe in a virus like COVID, these things are going to go in there and try to find it and kill it. Now, does it work all the time? No, we're wearing masks, right? Because we need, that immunity from it, and then we'll have a better response. So there's a new study that found that inhaled e-cigarette vapor damages those macrophages, and that hampers their ability to protect the surfactant and therefore the lungs. So that's another reason that we need to vaccinate these people as well, because they're damaging their natural immunity.